11.5 Areas of Regular Polygons. We'll be talking about areas of equilateral triangles and of polygons using an apothem and perimeter. The first one we're going to be talking about is area of an equilateral triangle. Now, we already know how to find the area based on half times the height times the base, but another quick way we can find the area of an equilateral triangle is to use 1/4 times side squared times square root of 3. And the way that formula is derived is if we have an equilateral triangle where all the angles are 60 degrees, and we say that the side is equal to 1, and if we draw a line perpendicular, and we take a look at this triangle right here, we can calculate that this is half, and then this would have to be the height, square root of 3 over 2. So half times 1 times square root of 3 over 2 gives you square root of 3 over 4. And again, that side squared comes because we have 1 times itself. A couple of quick definitions. The first is the radius of a polygon is where a segment joining the center to any vertex. And an apothem is the segment joining the center to the midpoint of any side. So again, the radius goes from the center to the vertex, where an apothem is from the center to the midpoint of the side. A few quick things we're going to be talking about, or good references to know, is that all apothems of regular polygons are congruent. Only regular polygons have apothems. An apothem is a radius of a circle inscribed in the polygon, not circumscribed, but inscribed. The apothem is the perpendicular bisector of the side. The radius of a regular polygon is the radius of a circle circumscribed about the polygon. The radius of a regular polygon bisects an angle of the polygon. If all the radii of a regular polygon are drawn, the polygon will be divided into congruent isosceles triangles. We'll have one more theorem for this lesson, and that's Theorem 107, which tells us the formula for a regular polygon. And you can find the area by taking half times A times P, where A is the apothem and P is going to be the perimeter. We're going to take a look at 3 quick examples. The first one is we're going to find the area of a regular hexagon whose side is 28. So to find the area, we'll do half times A times P. Right away, we'll know that the perimeter will be 168 because it's a hexagon, so we'll times 28 times 6, and that will be 168. So now what we need to find is the apothem. And we'll do that by doing a couple of things. We'll draw some radii, and we'll also draw an apothem. What we'll need to know is we'll need to know what the angle is of each of these vertices, so that we'll be able to know what this angle is in here. Now, if you remember back a few chapters, we can find that angle by doing the number of sides minus 2 times 180. So that would be 6 minus 2, which is 4 times 180, which is 720. Divide that by 6. Each angle will equal 120 degrees. So if this is 120 degrees, this angle has to be 60, this angle has to be 30. Now, since each apothem is a perpendicular bisector, that means that this length right in here has to be 14. This would be 28, and this would be 14 square root of 3. And that would be our apothem right there. When you go ahead and do the calculations, that will give you the area, which would be 2,352 times square root of 3. Our second example tells us that the area of an equilateral triangle ABC is 25 square root of 3. And what we want to do is find the length of the apothem. Well, we know that we can calculate the area of an equilateral triangle by doing side squared over 4 times square root of 3. So if we know that area is 25 square root of 3, we can just set that equal to it and then solve. The square root of 3 will cancel. I can multiply by 4. Get 100 equals s squared. S equals 10. So each side is going to be 10. But we want to know what the apothem is. And so our perimeter equals 30. And we also know that we can calculate the area by doing half times A times P. And we're already told that the area is 25 square root of 3. So we'll substitute that in. Right, perimeter is 30. We'll end up being 50 square root of 3 equals 30 times A. And then when we calculate that out, A will give us 5 over 3 square root of 3 for our apothem. And finally, our last example. If we have a regular polygon with an area of 120 and has a perimeter of 36, we want to find the length of the apothem of the polygon. Well, we know that a regular polygon for the area can be calculated by half times A times P. We know that the perimeter is 36, so that can be substituted here. And we know that the area is 120, so that can be substituted in there. So 120 equals half A times 36. 240 equals 36 times A. And finally, A, our apothem, equals 6.6. There are quite a few formulas that we're learning in this section and over the past few sections, so make sure you're staying on top of those and you're reviewing those nightly.